The most practical way to make electricity is to rotate a coil within the poles of a permanent magnet. Again, this one would have been hard to draw, so I'm going to try and talk you through it. We got a big south pole on the left, we got a big north pole on the right. If that's all that was going on, then there'd be magnetic field lines pointing. They always point from north to south. So kind of in the background of this, you've got magnetic field lines pointing from right to left. Lenz's law is all about opposing the change. So let's say our coil starts in this orientation and a split second later it's rotated 90 degrees. It might get a little bit ugly, but I'm going to bring an actual coil in here. So we've got that coil. Before the rotation starts, the magnetic field through that coil happens to be pointing from right to left. There's a magnetic field that way. As we rotate it 90 degrees, now all of a sudden, as far as the coil is concerned, there's no magnetic field lines pointing through them anymore. The magnetic field line is kind of pointing across the coils. That doesn't really do anything to a coil. To get this effect, it's about the magnetic field passing through it. So when the coil was this way, there was a lot of magnetic field pointing to the left in the coil. But when it rotates 90, now all of a sudden there's no magnetic field pointing to the left. The coil doesn't like that. The change from here to here was we're taking away magnetic field lines that happen to be pointing to the left. So to fight that, electricity flows through the coil to create magnetic field lines that also point to the left, to sort of add the leftward that it was losing. It always opposes a change. If the changes were losing magnetic field lines pointing to the left, then this one's going to make magnetic field lines pointing to the left. So positive flow in the question, positives would go up out of the page when they're sort of down here, across the top going upward, and tuck into the page when they're over there. Once the coil gets to here, now there's no more magnetic field lines pointing in it. As it rotates through the next 90 from here to here, the change is as it rotates, it gets more and more magnetic field lines pointed to the left through it. So from here to here, the changes we're adding field lines that point to the left. It's almost like we stabbed a north pole into it. It doesn't like us stabbing a north pole into it. It doesn't like us adding to the left, so it creates electricity to make a magnetic field pointing to the right. So out of the page above the coil, down when it's at the top of the coil, into the page below the coil. It's almost as if this part of the rotation is almost as if we stabbed a north pole in. For the next quarter turn, it's kind of the opposite. It's almost like we took the north pole out. We went from magnetic field lines pointing to the left in the coil. Now there's no magnetic field lines pointing to the left. So during that rotation, the electricity switches to make magnetic field lines pointing to the left. So for this quarter of a rotation, the electricity goes this way. Then for the next quarter of the rotation, the electricity is going to go that way. For the next quarter, it's going to reverse again. Every quarter, oops, I hope I didn't screw up. Every quarter, the direction of the electricity kind of reverses. I might have got lost there at the end. If we don't wire this correctly, well, not the correct isn't the right word. Depending how we wire this, we could turn this into an AC generator or we could turn this into a DC generator. That depends on whether we do a split ring for DC or two separate rings for AC. But as this thing tumbles, we're going to get electricity. The change just keeps on happening, taking away magnetic field lines in the coil, adding magnetic field lines in the coil, taking away, adding, taking away, adding. So we get the sloshing of electricity back and forth. In a perfect world, you can describe the direction, but what's more important is what's coming next. We're actually going to develop an equation and predict how many volts we can make in that coil.